Hello students, welcome to this lecture on binomial theorem. So in this lecture we will discuss NCERT section 7.2 and then we will solve NCERT examples 1 to 4 and then we will solve NCERT exercise 7.1. This is disclaimer. First of all, we are going to explore some special cases of the binomial theorem. Then we will solve NCERT examples 1, 2, 3 and 4. After that, we shall solve exercises from NCERT exercise 7.1. So let's look at some special cases. Okay, so we are going to discuss the binomial theorem, a fundamental concept in algebra. It helps us expand expressions of the form a plus b whole to the power n. Okay, so where a and b are any real numbers and n is a positive integer. If a and b are real numbers and n is a positive integer, then a plus b whole to the power n, this is equal to nc0 a to the power n plus nc1 a to the power n minus 1 times b plus dot 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 ncn b to the power n. Okay, and this statement is denoted as p of n. Now let's look at how we can express the binomial theorem using sigma notation. Okay, so let's see. The theorem can be written more concisely as a plus b whole to the power n is equal to summation k equal to 0 to n nck. Nck means n choose k times a to the power n minus k into b to the power k. Okay, so this is the sigma notation representation of a plus b whole to the power n. Now let's define the binomial coefficients which are crucial to the binomial theorem. Okay, so the binomial coefficient denoted as n choose r, and it is calculated as n factorial upon r factorial times n minus r factorial. Okay, so ncr equal to n factorial upon r factorial times n minus r factorial are the binomial coefficients where exclamatory notation represents factorial. Okay, and factorial means the product of all integers up to that specific number. Okay, now we will start by examining different cases. Okay, so we will start from case 1. So we are beginning with the expression x minus y whole to the power n. Now let's begin by recalling the general form of the binomial expansion. We know that for any two terms a and b, okay, a and b are real numbers, the expression of a plus b whole to the power n is given by the formula nc0 a to the power n plus nc1 a to the power n minus 1 times b plus dot 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 ncn b to the power n. Now let's apply this formula to our specific case by substituting a equal to x and b equal to minus y. Okay, so by substituting a equal to x and b equal to minus y, we have x minus y whole to the power n. Okay, so this can be also written as x plus minus y whole to the power n, and we can write this as the sum from k equal to 0 to n of n choose k x to the power n minus k times minus y to the power k. Okay, and you can also write it as this is equal to summation from k to 0 to n minus 1 to the power kn minus 1 to the power k. Okay, n choose k x to the power n minus k into y to the power k. Now simplifying further, we get x minus y whole to the power n is equal to nc0 x to the power n minus nc1 x to the power n minus 1 times y plus nc2 x to the power n minus 2 times y square plus dot dot dot, okay, and so on, plus minus 1 to the power n ncn y to the power n. Okay. Now, it's important to observe that the terms in the expansion alternate between positive and negative. Okay, here in the expansion, you can see the first term is positive, the second term is negative, then third term is positive, then fourth term will be negative. Okay, so it actually alternate between positive and negative. Okay, this pattern is due to the minus y to the power k. Okay, done. So which introduces a negative sign for odd values of k. Now let's move on to the case 2, where we consider the expansion 1 plus x whole to the power n. Again, we know that Pn such that a plus b whole to the power n equal to n choose c, n choose 0, a to the power n plus n choose 1, a to the power n minus 1 times b plus dot 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 n choose n, b to the power n. Okay, so now we will substitute here a equal to 1 and b equal to x. So by substituting a equal to 1 and b equal to x, we simplify the expression to 1 plus x whole to the power n. So the expansion becomes 1 plus x whole to the power n equal to nc0 plus nc1 times x plus nc2 x square plus dot 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 ncn x to the power n. Okay, so notice here how each term is a positive power of x. Okay, so reflecting the absence of the negative signs here. So here in this case, all the terms are positive. Okay. Finally, let's consider case 3, where we have the expansion 1 minus x whole to the power n. Okay, so this case is similar to the previous one. Okay, that is case 1. Okay, so here we will also see the terms will alternate between positive and negative. For this case, we substitute a equal to 1 and b equal to minus x into the binomial expansion formula. So the expansion for 1 minus x whole to the power n equal to nc0 minus nc1 times x plus nc2 x square minus dot 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 plus minus 1 to the power n ncn x to the power n. Okay, clear? I think it's clear to all of you and you are getting my point. Now we know that Pn such that a plus b whole to the power n equal to n choose 0 a to the power n plus n choose 1 a to the power n minus 1 times b plus dot 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 n choose n b to the power n. Okay, let's see what happens when we replace b by minus b in the expansion a plus b whole to the power n. Okay, we get here Pn such that a plus minus of b whole to the power n, this is equal to n choose 0 a to the power n plus n choose 1 a to the power n minus 1 times minus b plus dot 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 plus ncn minus b whole to the power n. Okay, now let's add the two expansions a plus b minus a plus b whole to the power n and a plus minus b whole to the power n. Okay, then we get here a plus b whole to the power n plus a minus b whole to the power n. This is equal to 2 times nc0 a to the power n b to the power 0 plus nc2 a to the power n minus 2 times b square plus dot nc4 a to the power n minus 4 times b to the power 4 and plus dot dot dot. Okay, so notice how only the terms with even powers of b remain here, okay, in the expansion. Now a plus b whole to the power n plus a minus b whole to the power n, this is simply equal to 2 times terms at odd places, okay. Now let's subtract a minus b whole to the power n from a plus b whole to the power n. Then we get a plus b whole to the power n minus a minus b whole to the power n. This is equal to 2 times nc1 a to the power n minus 1 times b to the power 1 plus nc3 a to the power n minus 3 times b to the power 3 plus dot dot dot, okay. So this also can be written as a plus b whole to the power n minus of a minus b whole to the power n. This is equal to 2 times sum of terms at even places, okay. Clear? I think it is clear to all of you, okay. So now let's move to the next concept. So let's look at example 1, okay. So in this example we will expand x square plus 3 upon x whole to the power 4 where x is not equal to 0, okay. So first of all, try it yourself. How would you approach this example, okay. So we will be expanding the expression x cube plus 3 upon x whole to the power 4 where x is not equal to 0, okay. So let's solve this example step by step. So we need to expand x square plus 3 upon x whole to the power 4 where x is not equal to 0. We know that for any positive integer n, the expansion of a plus b whole to the power n is given by Pn such that a plus b whole to the power n equal to nc0 a to the power n plus nc1 a to the power n minus 1 times b plus dot 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 ncn b to the power n. The binomial coefficient in the expansion is NCR, okay, and NCR is calculated using the formula n factorial upon r factorial times n minus r factorial, where n factorial is the product of all positive integers up to n. Now in our example we have n equal to 4, a equal to x square and b equal to 3 by x, okay. So these values will be substituted in the binomial theorem to find the expanded form of the given expansion, okay. By applying the binomial theorem to our specific values, we can start expanding the expression as x square plus 3 upon x whole to the power 4 is equal to 4c0 x square whole to the power 4 plus 4c1 x square whole to the power 3 into 3 by x plus 4c2 x square whole to the power 2 into 3 by x whole square plus 4c3 x square times 3 by x up to the power 3 plus 4c4 3 by x whole to the power 4, okay. So now we will simplify this and we will get the expanded form of the given expression. Let's start by calculating the binomial coefficient for n equal to 4 and r equal to 0. Okay, then 4c0, this is equal to 4 factorial upon 0 factorial times 4 minus 0 factorial. And this is equal to 4 factorial upon 4 factorial and this is equal to 1. Since 0 factorial is 1. Okay. Next, we calculate the coefficient for r equal to 1. So 4c1 equal to 4 factorial upon 1 factorial times 4 minus 1 factorial. This is equal to 4 factorial upon 1 factorial into 3 factorial. And after simplifying, this is equal to 4. Since 1 factorial is 1, 3 factorial is 6. Okay. Now, for r equal to 2, we find 4c2. Okay. So this is 4 factorial upon 2 factorial times 4 minus 2 factorial. this is equal to 4 factorial upon 2 factorial into 2 factorial, this is equal to 6. Since 1 factorial is 1, 3 factorial is 6, 4 factorial is 24. Clear? Same as we can find the values of 4C3, 4C4. So then we get the coefficients are 4C0 is 1, 4C1 is 4, 4C2 is 6, 4C3 is 4, 4C4 is 1. Then put the values in the expansion, x square plus 3 upon x whole to the power 4. Then we get x square plus 3 upon x whole to the power 4. This is equal to x to the power 8 plus 4 times x to the power 6 into 3 by x plus 6 times x to the power 4 into 9 by x square plus 4 times x square into 27 upon x cube plus 81 upon x to the power 4. Hence, we simplify the expression to get the expanded form. So the expanded form is x square plus 3 upon x whole to the power 4. This is equal to x to the power 8 plus 12 times x to the power 5 plus 54 times x square plus 108 upon x plus 81 upon x to the power 4. Now, let's look at an example of using the binomial theorem. So now we will look at example number 2. Okay, so in this example, we are asking to compute 98 to the power 5. Okay, so students, first of all, try it yourself. How can you solve this example? Okay. So we will compute here 98 to the power 5. Okay. So we need to compute 98 to the power 5. And the binomial theorem provides a way to expand expression of the form a plus b whole to the power n. Okay, for any positive integer n, and this expansion is a powerful tool for simplifying calculations. Okay, so now we are applying binomial theorem to compute 98 to the power 5. So since we will know binomial theorem as a plus b whole to the power n, this is equal to nc0 a to the power n plus nc1 a to the power n minus 1 times b plus dot 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 plus ncn b to the power n. Okay, so using this theorem, we can easily now calculate 98 raised to the power 5. Now, first of all, see here binomial coefficients NCR. This is equal to n factorial upon r factorial times n minus r factorial. Okay, where n factorial is n times n minus 1 times dot 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 4 times 3 into 2 into 1. So to make our calculation easier, we will express 98 as a sum of difference of numbers that are simpler to work with. Okay, so let's see how can we express 98. So we can write 98 as 100 minus 2. Then use the binomial theorem. Therefore 98 to the power 5, this is equal to 100 minus 2 to the power 5. Now see here, value of n is 5 here. A is equal to 100 and b is equal to minus 2. Now we will substitute these values into the binomial theorem. So we will compute now 98 raised to the power 5 using the binomial theorem. So let's start by expanding 100 minus 2 whole to the power 5. This is equal to 5c0, 100 to the power 5 minus 5c1, 100 to the power 4 into 2 plus 5c2, 100 to the power 3 into 2 square minus dot dot dot. Okay, minus 5c5 2 to the power 5. Okay, so this is the expanded form of 100 minus 2 whole to the power 5. Now let's calculate the first binomial coefficient for n equal to 5, r equal to 0. Then 5c0, this is equal to 5 factorial upon 0 factorial times 5 minus 0 factorial, and since 0 factorial is 1, so this is equal to 5 factorial upon 5 factorial, and this is equal to 1. Okay. Now next for r equal to 1, so 5c1, so this is equal to 5. Okay, you can easily calculate it. And for r equal to 2, 5c 2 is 5 factorial upon 2 factorial into 3 factorial. This is equal to 10. And same as we can find the value of 5c3, 5c4 and 5c5. Okay, so try to find the values of 5c3, 5c4 and 5c5. Now see here, binomial coefficients for our expansion are 5c0 is 1, 5c1 is 5, 5c2 is 10, 5c3 is 10, 5c4 is 5 and 5c5 is 1. Okay, so now these coefficients will be used to multiply the respective terms in our binomial expansion. Let's substitute these coefficients into our expansion and we get here 100 minus 2 whole to the power 5. This is equal to this expression. Okay, you can see here, and this is simply equal to 1 0 0 4 0 0 8 0 0 minus 1 0 0 8 0 0 3 2. Okay, and finally we find that 98 raised to the power 5, this is equal to 9039207968. Okay, and this is our final answer. So I hope this example is clear to all of you. Now let's look at example 3. So in this example we have to compare two numbers, 1.001 to the power 1 0 0 0 0 0 6 times. Okay, 160 and or 10,000. So which number is greater than, okay, which number is larger, that we have to find here. So let's solve this example step by step. So we need to compute which is larger between 1.01 to the power 160 or 10,000. Okay, which one is correct or which one is larger, that we have to find out. We know that for any positive integer n, the expression of a plus b whole to the power n is given by Pn such that a plus b whole to the power n, this is equal to nc0 a to the power n plus nc1 a to the power n minus 1 times b plus dot 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 ncn b to the power n. Now the binomial coefficient ncr, this is equal to n factorial upon r factorial times n minus r factorial, where n factorial, this is equal to n times n minus 1 times dot 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 4 times 3 into 2 into 1. Now splitting 1.01 and using binomial theorem to write the first few terms. So first splitting 1.01 as 1 plus 0.01. So value of n is here n60, a equal to 1 and b equal to 0.01. These values will substitute in the binomial theorem. So we can write it as 1.01 to the power 160 equal to 1 plus 0.01 to the power 160. Okay, and this is equal to 1.01 to the power 160 equal to 160 c0 plus 160 c1 into 0.01 plus other positive terms. Okay, and this implies 1.01 to the power 160 equal to 1 plus 160 into 0.01 plus other positive terms. Okay, and here this is equal to 1 plus 10,000 plus other positive terms. Okay, so here 1.01 to the power 160 is greater than 10,000. Okay, hence 1.01 to the power 160 is greater than 10,000. Clear? I think it's clear to all of you. So now let's move to the next example. So in this example, we have to use binomial theorem to prove that 6 to the power n minus 5n always leaves remainder 1 when divided by 25. Okay, so our goal is to prove that 6 to the power n minus 5n always leaves remainder 1 when divided by 25. So we will use binomial theorem to prove that the expression 6 to the power n minus 5n always leaves a remainder of 1 when divided by 25. For any two terms a and b, if we can find numbers q and r, then such that a equal to bq plus r. Okay, then we say that b divides a with q as quotient, quotient and r as remainder. Thus, in order to show that 6 to the power n minus 5n leaves remainder 1 when divided by 25, so this can be expressed in the form, we can express 6 to the n minus 5n, this is equal to 25k plus 1. Okay, so we have to prove that 6 to the power n minus 5n, this is equal to 25 times k plus 1, where k is some natural number. The binomial theorem for the expansion 1 plus a whole to the power n. So 1 plus a whole to the power n can be expressed as nc0 plus nc1 times ba plus nc2 a square plus dot 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 ncn a to the power n. Now we will prove that the expression 6 to the power n minus 5n always leaves a remainder of 1 when divided by 25. So for a equal to 5, we get 1 plus 5 whole to the power n, this is equal to nc0 plus nc1 times 5 plus nc2 5 square plus dot 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 ncn into 5 to the power n. That is 6 to the power n, this is equal to 1 plus 5n plus 5 square times nc2 plus 5 cube into nc3 plus dot 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 5 plus 5 to the power n. That is 6 to the power n minus 5n equal to 1 plus 5 square times nc2 plus nc3 times 5 plus dot 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 plus 5 to the power n minus 2. Or 6 to the power n minus 5n equal to 1 plus 25 times nc2 plus 5 times nc3 plus dot 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 5 to the power n minus 2. Or 6 to the power n minus 5n, this is equal to 25 times k plus 1, where k is equal to nc2 plus 5 times nc3 plus dot 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 plus 5 to the power n minus 2. So this shows that when 6 to the power n minus 5n divided by 25 leaves remainder 1. Clear? I hope this example is clear to all of you. Now we will discuss how to find middle terms for an expansion. Okay, so the location of the middle terms in the expansion of a plus b whole to the power n depends on whether the total number of terms a plus 1 is odd or even. Okay, so let's start with case 1, when the index n is even. The total number of terms n plus 1 then is odd. There is only one middle term in this case. When the position of middle term will be n by 2 plus 1 term. Okay, and how to find? So use the general term formula, that is tr plus 1 with r equal to n by 2. In the expansion of a plus b whole to the power n, general term r plus 1th term is given by tr plus 1 equal to ncr a to the power n minus r times b to the power r. Now middle term is given by t n by 2 plus 1, this is equal to nc n by 2 a to the power n minus n by 2 into b to the power n by 2. This is equal to nc n by 2 into a to the power n by 2 into b to the power n by 2. Now let's look at an example to clarify our concept. Okay, so here we consider the expansion of the expression x plus y whole to the power 8 when n equal to 8 here. Okay, the middle term is the 8 by 2 plus 1, that is fifth term, that is t5. So now we are focusing on the case 2 where the index n is odd. The total number of terms n plus 1 in this case is even. There are two middle terms in this case. Positions of middle terms are n plus 1 by 2 term and n plus 1 by 2 plus 1 terms. How to find? The first middle term is t n plus 1 by 2. Use here r equal to n plus 1 by 2 minus 1, that is n minus 1 by 2. Okay, and second middle term t n plus 1 by 2 plus 1. Use here r equal to n plus 1 by 2. Now let's take an example. For x plus y to the power 7, here n is 7, this is odd number. So in this case we will get two middle terms. The middle terms are the 7 plus 1 by 2, that is fourth term, that is t4, and the 4 plus 1, the fifth term, that is t5. Clear? So I hope it's clear. Now we will discuss binomial coefficient. Okay, so in the binomial expression we have Pn such that a plus b whole to the power n, this is equal to nc0 a to the power n plus nc1 a to the power n minus 1 times b plus dot 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 plus ncn b to the power n. The coefficients nc0, nc1, nc2 dot 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 ncn are known as binomial or combinatorial coefficients. Putting here a equal to b equal to 1, and then we get nc0 plus nc1 plus nc2 plus dot 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 plus ncn, this is equal to 2 to the power n. Thus the sum of all the binomial coefficients is equal to 2 to the power n. Now let's observe in the binomial expression we have a plus b whole to the power n equal to nc0 a to the power n plus nc1 a to the power n minus 1 times b plus dot 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 ncn b to the power n. Okay, here nck represents the binomial coefficient and which tells us how many ways we can choose k elements from a set of n elements. Again, putting here a equal to 1 and b equal to minus 1, then we get nc0 a to the power n minus nc1 a to the power n minus 1 times b plus dot 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 minus 1 to the power n ncn b to the power n, this is equal to 0. And rearrange the terms, then we get here nc0 plus nc2 plus nc4 plus dot dot dot, this is equal to nc1 plus nc3 plus nc5 plus dot dot dot. Thus the sum of all the odd binomial coefficients is equal to the sum of all the even binomial coefficients, and each is equal to the 2 to the power n upon 2, that is equal to 2 to the power n minus 1. So we obtain here this result nc0 plus nc2 plus nc4 plus dot dot dot, this is equal to nc1 plus nc3 plus dot dot dot, this is equal to 2 to the power n minus 1. Clear? I hope this is clear to all of you. Now we will solve NCERT exercise 7.1. So look at question number 1. So in this question we are asking to expand the expression 1 minus 2x whole to the power 5 using the binomial theorem. Our focus will be on expanding the expression 1 minus 2x whole to the power 5. So let's solve this question step by step. So we need to expand 1 minus 2x whole to the power 5. Notice how this expression is in the form a plus b whole to the power n, where a is here 1 and b is minus 2x and n is 5. So if a and b are any real numbers and n is a positive integer, then a plus b whole to the power n, this is equal to nc0 a to the power n plus nc1 a to the power n minus 1 times b plus dot 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 ncn b to the power n. we can also write it as a plus b whole to the power, this is equal to summation k equal to 0 to n nck a to the power n minus k into b to the power k for n belongs in natural number, where NCR equal to n factorial upon r factorial times n minus r factorial for 0 less than equal to r less than equal to n. Here we can see that a equal to 1, b equal to minus 2x and n equal to 5. By using binomial theorem, the expression 1 minus 2x whole to the 5 can be expanded as 1 minus 2x whole to the 5, this is equal to 5c0, 1 to the 5 minus 5c1 on to the 4 into 2x plus 5c2, 1 to the power 3 times 2x to the power 2 minus 5c3 1 square into 2x to the power of 3 plus 5c4 1 to the power 1 into 2x to the power 4 minus 5c5 2x to the power 5. For n equal to 5, r equal to 0, we have in 5c0, this is equal to 5 factorial upon 5 factorial, this is equal to 1. And for r equal to 1, 5c1 is 5. And for r equal to 2, 5c2 is 10. Similarly, we can calculate the remaining coefficients 5c3, 5c4 and 5c5. So these are 10, 5 and 1 respectively. So our coefficients are 5c0 is 1, 5c1 is 5, 5c2 is 10, 5c3 is 10, 5c4 is 5, 5c5 is 1. Now let's substitute these coefficients back into our expansion of 1 minus 2x whole to the power 5. So we get 1 minus 2x whole to the power 5, this is equal to 1 minus 5 times 2x plus 4 10 times 4x square minus 10 times 8x cube plus 5 times 16 times x to the power 4 minus 32 times x to the power 5. Hence 1 minus 2x whole to the power 5, this is equal to 1 minus 10x plus 40x square minus 80x cube plus 80x to the power 4 minus 32x to the power 5. So I hope it's clear to all of you. Now let's move to the next question. In this question, we are asking to expand the expression 2 upon x minus x by 2 to the power 5. Okay, so here we will use binomial theorem to expand this. Our focus will be on the expression 2 upon x minus x by 2 whole to the power 5. Okay, so let's expand the expression. So we need to expand the expression 2 upon x minus x by 2 raised to the power 5. If a and b are real numbers and n is positive integer, then a plus b raised to the power n, this is equal to nc0 e to the power n plus nc1 e to the power n minus 1 times b plus dot 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 plus ncn b to the power n, where ncr is equal to n factorial upon r factorial times n minus r factorial for 0 less than equal to r less than equal to n. Here we can see that a equal to 2 upon x, b equal to minus x by 2 and n equal to 5. So now we will be substituted these values. So by using binomial theorem, the expansion of expression as for n equal to 5, r equal to 0, then 5c0 is simply 1. For r equal to 1, 5c1 is 5. For r equal to 2, 5c2 is 10. Same as we can find the value of 5c3, 5c4 and 5c5. Okay, so the coefficients are 5c0 is 1, 5c1 is 5, 5c2 is 10, 5c3 is 10, 5c4 is 5 and 5c5 is 1. Now put these values in the expression 2 upon x minus x by 2 whole to the power 5. We get here 2 upon x minus x by 2 raised to the 5, this is equal to 5c0 2 upon x to the power 5 minus 5c1 2 upon x raised to the power 4 into x by 2 plus dot 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 plus 5c4 2 upon x into x by 2 whole to the power 4 minus 5c5 x by 2 whole to the power 5. So using the binomial theorem, we obtain the expansion of 2 upon x minus x by 2 raised to the 5. This is equal to 32 upon x by x to the 5 minus 5 times 16 upon x to the 4 into x by 2 plus 10 times 8 by x cube times x square upon 4 minus 10 times 4 upon x square times x cube upon 8 plus 5 times 2 upon x into x to the 4 upon 16 minus x to the 5 upon 32. Hence, 2 upon x minus x by 2 raised to the 5. This is equal to 32 upon x to the 5 minus 40 upon x cube plus 20 upon x minus 5x plus 5 upon 8 x cube minus x to the 5 upon 32. So I hope this question is clear to all of you. So now let's move to the next question. Look at question number 3. In this question, we are asking to expand the expression 2x minus 3 raised to the 6. So now we are going to solve this question step by step. So we need to expand the expression 2x minus 3 raised to the power 6. So if a and b are real numbers and n is a positive integer, then a plus b raised to the power n, this is equal to nc0 a to the power n plus nc1 a to the power n minus 1 times b plus dot 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 plus ncn b to the power n. So now the binomial coefficient NCR is calculated as n factorial upon r factorial times n minus r factorial for 0 less than equal to r less than equal to n. Here we can see that a equal to 2x, b equal to minus 3 and n equal to 6. Now we will substitute these values into the binomial theorem. So by using binomial theorem, the expression will be expanded as by using binomial theorem, the expression 2x minus 3 raised to the power 6 can be expanded as 2x minus 3 raised to the power 6. This is equal to 60. 2x whole to the power 6 minus 5, 61. 2x raised to the power 5 times 3 plus 62. 2x raised to the power 4 into 3 square minus plus dot dot dot. Plus term will be plus 6c6 3 to the power 6. For n equal to 6 and r equal to 0, then a 6 is 0. This is equal to simply 1. And for r equal to 1, 61 is 6. And for r equal to 2, 62 is 15. Similarly, we can find the remaining coefficients 63, 64 and 65 and 66. Okay, so the binomial coefficients are 60 is 1, 61 is 6, 62 is 15, 63 is 20, 64 is 15, 65 is 6, 66 is 1. Now put these values in the expansion 2x minus 3 raised to the 6, then we get 2x minus 3 raised to the 6. This is equal to 64 times x to the 6 minus 6 times 32 times x to the 5 times 3 plus 15 times 16 times x to the 4 times 9 minus 20 times 8x cube times 27 plus 15 times 4x square times 81 minus 6 times 2x into 243 plus 729. So finally, we get the expression in the expanded form as 2x minus 3 raised to the power 6 is 64x to the power 6 minus 576 x to the power 5 plus 2160 times x to the 4 minus 4320 times x to the 3 plus 4860 times x square minus 2916 times x plus 7029. 700. Okay, 729. Plus 700 plus 729. Now we will look at question number 4. So we have to expand the expression x by 3 plus 1 by 6 raised to the 5. So the expression we have x by 3 plus 1 by 6 raised to the 5, and we have to expand this expression. So we need to expand the expression x by 3 plus 1 by 6 raised to the 5. So if a and b are real numbers and n is a positive integer, then a plus b raised to the n is nc0 x to the power a to the power n plus nc1 a to the power n minus 1 times b plus dot 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 plus ncn b to the power n, where ncr is n factorial upon r factorial times n minus r factorial for 0 less than equal to r less than equal to n. Here we can see that a equal to x by 3, b equal to 1 by 3 and n equal to 5. So by using binomial theorem, the expression x by 3 plus 1 by x raised to the 5 can be expanded as so x by 3 plus 1 by x raised to the 5, this can be written as 5c0 x by 3 raised to the 5 plus 5c1 x by 3 to raised to the 4 into 1 by x plus 5c2 x by 3 whole to the 3 into 1 by x whole square and plus dot dot 5c5 times 1 by x raised to the 5. For n equal to 5, r equal to 0, 5c0 is 1, r equal to 1, 5c1 is 5, r equal to 2, 5c2 is 10. And similarly, we can find the values of 5c3, 5c4, 5c5. The coefficients are 1, 5, 10, 10, 5, 1. Put these values in expansion, then we get x by 3 plus 1 by x raised to the 5. This is equal to x to the 5 upon 243 plus 5 times x to the 4 upon 81 times 1 by x plus 10 times x cube upon 27 times 1 by x square plus 10 times x square upon 9 into 1 by x cube plus 5 times x by 3 times 1 by x to the 4 plus 1 by x to the 5. Hence, x by 3 plus 1 by x raised to the 5, this is equal to x to the 5 upon 243 plus 5x cube upon 81 plus 10x upon 27 plus 10 upon 9x plus 5 upon 3 times x cube plus 1 upon x to the 5. So I hope this question is clear to all of you. So now let's move to the next question. So in this question, we are asking to expand the expression x plus 1 by x raised to the power 6. So students, first of all, try it yourself and then see the solution. So let's expand the expressions step by step. So we need to expand the expression x plus 1 by x raised to the power 6. So if a and b are real numbers and n is a positive integer, then a plus b raised to the power n is nc0 a to the power n plus nc1 a to the power n minus 1 times b plus dot 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 plus ncn b to the power n, where ncr is n factorial upon r factorial times n minus r factorial for 0 less than equal to r less than equal to n. Here we can see that a equal to x, b equal to 1 by x and n equal to 6. So by using binomial theorem, the expression x plus 1 by x raised to the power 6 can be expanded as so x plus 1 by x raised to the power 6, this is equal to 60 x to the power 6 plus 61 x to the 5 times 1 by x plus other terms, okay, and the last term will be 66 times 1 by x raised to the power 6. For n equal to 6, r equal to 0, then 60 is 1. For r equal to 1, 61 is 6. For r equal to 2, 6c2 is 15. Similarly, we can find the remaining coefficients 63, 64, 65 and 66. Okay, these are 20, 15, 6 and 1. So put these values in the expansion and we get x plus 1 by x raised to the power 6 is x to the power 6 plus 6 times x to the power 5 plus 1 by x plus 15 times x to the power 4 times 1 by x square plus 20 times x to the power cube plus into 1 by x cube plus 15 times x square plus 1 by x to the power 4 plus 6 times x into 1 by x to the power 5 plus 1 by x to the power 6. Hence, x plus 1 by x raised to the power 6 is equal to x to the power 6 plus 6 times x to the power 4 plus 15 times x square plus 20 plus 15 upon x square plus 6 upon x to the 4 plus 1 plus 1 upon x to the 6. Okay, clear? I hope it's clear to all of you. That's all for today's lecture, and thank you very much to all of you.